everyone, this is Demi Friends Vindaz and it's our 4th month of doing videos in science for the high school level. For this month, we're assigned to a new topic and it's all about the space explorations. But before anything else, don't forget to like, subscribe, and ring the bell button in our YouTube channel.
What is space exploration? Space exploration is the investigation by means of crewed and uncrewed spacecraft of the reaches of the universe beyond Earth's atmosphere and the use of the information so gained to increase knowledge of the cosmos and benefit humanity. Humans have always looked at the heavens and wondered about the nature of the objects seen in the night sky. Well, before technology made these achievements possible, space exploration had already captured the minds of many people, not only aircraft pilots and scientists, but also writers and artists. The stronghold that space travel has always had on the imagination may well explain why professional astronauts and lay people alike contend at their great peril. The direct benefits of exploration include the generation of scientific knowledge, the diffusion of innovation, and creation of markets, the inspiration of people around the world, and agreements forged between the countries engaged in exploration. The first space exploration that successfully launched and entered Earth's orbit on October 4, 1957 is the Sputnik 1. Sputnik 1 is the first humanity's artificial satellite that shocked the world, giving the former Soviet Union the distinction of putting the first human-made object into space. The word Sputnik originally meant fellow traveler, but has become synonymous with satellite in modern Russian. The pressurized sphere made of aluminum alloy had 5 primary scientific objectives. First, test the method of placing an artificial satellite into Earth orbit. Second, provide information on the density of the atmosphere by calculating its lifetime in orbit. Third, test ratio and optical methods of orbital tracking. Fourth, determine the effects of radio wave propagation through the atmosphere. And lastly, check principles of pressurization used on the satellites. Next is we have Soyuz 1967. Soyuz 1967 is a crewed spacecraft are designed to support human life for the human spaceflight portion of the mission. Soyuz is a series of spacecraft designed for the Soviet space program by the Korolev Design Bureau in 1960s that remain in service today, having made more than 140 flights. The Soyuz succeeded the Voskhod spacecraft and was originally built as part of the Soviet crewed lunar programs. The Soyuz spacecraft is launched on Soyuz rocket from Baikonur Cosmodrome in Kazakhstan. Next is Shenzhou. Shenzhou is a spacecraft developed and operated by China using Soyuz technology to support its crewed spaceflight program. The name is variously translated as Divine Vessel, Divine Craft, or Divine Ship. Its design resembles the Russian Soyuz spacecraft, but it is larger in size. The first launch was on 19 November 1999 and the first crewed launch was on October 15, 2003. In March 2005, an asteroid was named 8256 Shenzhou in honor of the spacecraft. The Chinese crewed spacecraft program was relaunched in 1992 with Project 921. Next is Hubble Space Telescope. Hubble Space Telescope is about the size of a large school bus. It weighs 24,500 pounds. That's just under 2 adult male African bush elephants. Hubble gathers energy from the sun using 2 25-foot solar panels. It requires much less power than one might think, averaging 2,100 watts of power usage. A hairdryer requires about 1,800 watts. Hubble orbits the Earth at a cruising speed of 17,000 miles per hour and takes 15 minutes to rotate 90 degrees. Hubble has observed locations more than 13.4 billion light-years away, meaning it has seen light that existed in the universe 13.4 billion years ago. Astronomers using Hubble data have published more than 13,000 journal articles, making it one of the most productive scientific instruments ever built. The Hubble Space Telescope gave astronomers their first views of a dust ring around a star and a dark gap dividing an immense dust disk around another star. Next is the Apollo 11. Apollo 11 was the first manned mission to land on the moon. The first steps by humans on another planetary body were taken by Neil Armstrong and Buzz Aldrin on July 20, 1969. The astronauts also returned to Earth the first samples from another planetary body. Apollo 11 achieved its primary mission to perform a manned lunar landing and return the mission safely to Earth, and paved the way for the Apollo lunar landing missions to follow. Photographs taken from lunar orbit provided broad views for the study of regional lunar geology. Apollo 11 was a culmination of the Apollo program and a massive national commitment by the United States to beat the Soviet Union in putting people on the moon. Next is we have the Space Shuttle Enterprise. Space Shuttle Enterprise was the first orbiter of the Space Shuttle system, rolled out on September 17, 1976, and it was built for NASA as part of the Space Shuttle program to perform atmospheric test flights after being launched from a modified Boeing 747. It was constructed without engines or a functional heat shield. Next is we have Voyager I. Voyager I is a space probe that was launched by NASA on September 5, 1977. Part of the Voyager program to study the outer solar system, Voyager I was launched 16 days after its twin, Voyager II. Voyager I is a spacecraft to reach interstellar space. Voyager I was actually the second of the twin spacecraft to launch, but it was the first to race by Jupiter and Saturn. The images it sent back have been used in school books and newspaper outlets for a generation. Also on board was a special record carrying voices and music from the Earth out into the cosmos. The primary science instrument on Explorer 1 was a cosmic ray detector designed to measure the radiation environment in Earth orbit. It entered Earth's atmosphere and burned up on March 31, 1970. After more than 58,000 orbits, Explorer 1 was the first US satellite and the first satellite to carry science instruments. Dan Allen theorized that the instrument may have been saturated by very strong radiation from a belt of charged particles trapped in a space by Earth's magnetic field. Explorer 1 revolved around Earth in a looping orbit that took it as close as 354 kilometers or 220 miles to Earth and as far as 2,515 kilometers or 1,563 miles. The primary science instrument on Explorer 1 was a cosmic ray detector designed to measure the radiation environment in Earth orbit. It entered Earth's atmosphere and burned up on March 31, 1970. After more than 58,000 orbits, Explorer 1 was the first US satellite and the first satellite to carry science instruments. Dan Allen theorized that the instrument may have been saturated by very strong radiation from a belt of charged particles trapped in a space by Earth's magnetic field. Explorer 1 revolved around Earth in a looping orbit that took it as close as 354 kilometers or 220 miles to Earth and as far as 2,515 kilometers or 1,563 miles. Here are the important key points of our lesson for this month. First, space exploration is the use of the astronomy and space technology to explore outer space. Second, while the exploration of space is carried out mainly by astronomers with telescopes, its physical exploration though is conducted both by unmanned robotic space probes and human space flight. Third, human space exploration helps to address fundamental questions about our place in the universe and the history of our solar system. Though addressing the challenges related to human space exploration, we expand technology, create new industries, and help to foster a peaceful connection with other nations. Fourth, the direct benefits of exploration include the generation of scientific knowledge, the diffusion of innovation and creation of markets, the inspiration of people around the world, and arrangement forged between the countries engaged in exploration. Lastly, there are 4 types of exploration: flyby, orbiter, rover, and human space explorations.